Thank you so much. It's been such a pleasure and a privilege to hear all the other speakers. And it's been very validating because I've been in this room and I think I would just estimate about 70% of the speakers have name-checked Don Norman, Design of Everyday Things. And I'm gonna do the same. I get so excited when people from a design background bring up that book. I'm a data engineer. I don't have a design background, but I've gotten very interested in user experience and then the results that you get at various levels of aggregation over large data sets. My company, ClearStory Data, is a cloud-based large-scale analytics platform, and my team does the exploratory data selection and visualization. It's on a D3 React stack. So we pay a lot of attention to user experience of data selection. And I had levels of aggregation just on my mind, you know, because when you change the granularity of a chart, it looks really different. And helping users understand why they get results at levels of aggregation, and helping users understand that you actually often have to aggregate if you want to visualize large data sets. You can't put all of your 4 billion rows onto a screen, even a big one, and you're certainly not going to get a chart. This is just a slide. This is just an example from a statistics book about how the same data set can yield very different results based on your level of aggregation. So one example is you could have a politician or a policy analyst say, our economy is in trouble because average income has gone down in significantly more states in the United States than it's gone up. And I'm totally making this up, but between 2013 and 2014, 48 of our 50 states had an average income that declined, and we need to take aggressive measures to turn things around and vote for someone else. And the exact same data set can say, actually, average income went up between 2013 and 2014. And you can have the same data set and come to exactly opposite conclusions, and you can have visualizations that will support opposite conclusions for policy analysts. And the reason for this is that our most populous states or our urban areas may have had incomes that went up. So you may have more individuals whose income increased, but more states, like some of the less populous states, maybe because of distribution of industry or whatever, both can be true. You can have a majority of states whose income went down. I used to do data analysis for a company that did emergency room analytics, and we'd have all these, we talked about like time to provider a lot, like how long are you gonna have to wait? If you get to an emergency room, how much staffing do you wanna do so people don't wait too long? And at the hospital level, there was tremendous variation in average wait times. Like we had some hospitals where you were gonna wait 40 minutes to see someone in the emergency room. You had hospitals where you would see someone in 2 minutes. And so there was the question of the population of patients, what is the average time to provider? Because if you look at it at the patient level, it was actually pretty high. It was like 30 minutes. But if you averaged hospital wait times, because a proportion of the hospitals had almost instantaneous time to provider, you would get something like 8 minutes. And these were very different conclusions to present to the CEO of the emergency room management company. You know, there were 1,000 hospitals, and you're saying, oh, you know, it's 8 minutes time to provider, we're doing great, or be like 30 minutes, you know, that's kind of long if you're in the emergency room. And it was all levels of aggregation. It was, are you doing, the hospitals that had a long time to provider tended to have the highest throughput. You would have one hospital, if they see 100,000 patients a year versus a hospital that sees 600 patients a year, you just have very different results for those averages. And so aggregation is super important. And levels of aggregation are very important, and you have to think about that for what you want to communicate, because doing an average of the hospitals, if you're doing hospital emergency room management, there were people who argued that that was reasonable, that an 8-minute wait time by hospital is actually a good metric, like that it doesn't undervalue some of the quicker hospitals. This is where I just had Don Norman on my mind. How many of you are designers? Great, awesome. Data engineers? Great. Data scientists? Okay, well I think that sums up to just about 100%. This is the famous Norman door, where you shouldn't give users things that are misleading. So for example, the handle indicates maybe you could pull on the door, but this is a door that only opens by pushing. And then this is my favorite Norman example, because every bathroom you go to, like figuring out how to get the hot water and the cold water and like which way to twist it, which handle is hot, which one is cold. And sometimes you have clues, like you'll have hot or cold, you'll have red or blue. And for this, you're really trying to do one thing, like you want to get kind of a warm temperature from the sink. And then you think about this and you think about data analytics workflow, where you're combining data sets from different sources. You don't know what to join on. You don't know how anything's going to pass the smell test because you don't even really have industry knowledge. Like choosing what features to offer the user, how to present them, what buttons, what to do underneath those buttons to give plausible results. One thing I love about this conference is this morning, the keynote speaker, I think he's the CEO of Analytic, was talking about how this industry is actually kind of young, and that the idea that you're getting big data onto a tiny screen, and that's the ultimate goal, and developing, well, he didn't really talk about developing workflows to support that. I am talking about developing workflows to support that. Because, I mean, Don Norman talks a lot about how if you misuse something, it's probably bad design, and you shouldn't blame yourself, and you shouldn't feel stupid. It's probably the designer's fault. And as designers of data products or engineers of data products, like, we have to be really thoughtful about what we're offering the users, because they're going to get results which can vary a lot in terms of sort of, proceeding from or having some kind of causal relationship to the data, having some kind of persuasive effect to the audience. Because, getting results is not hard. Often you can write a query and you'll probably get something. If you write it wrong and you don't get anything, that may be true too. It may be that there's nothing to get, but getting the right thing and then offering users a way to do that. At ClearStory, we talk a lot about sort of what should we give users buttons for. We still have like a lot of our operators are text-based, and you have to write kind of a custom DSL language. You have to use the Spark operators via our interface. And I'm comfortable with that. Personally, I even think of that as its own user interface. I mean, it isn't UX, but it's how I do things. One thing that I think a lot of products do, but that I think bears repeating, is from the availability of data types, we only show you visualization types that you could plausibly use. So this is just an example data set, and it's just a measure in a category. So you can do a bar chart, you can do a box plot, you can do a tree map, you can do pie chart, unless you have any like designers or people who hate pie charts, which you probably will, or a table visualization. But if you have location data, then you could look at a map visualization, and giving the users things that are useful based on the data. In this case, it's the data types, which is kind of a good one to start with. Really makes a difference in usability because you're not offering them visualizations that wouldn't be supported by the data. You're not giving them a handle to pull on a door that only opens outward. So we aren't the only ones doing this, but I thought it was super clever. So when you're thinking about granularity, like in the states down, individuals up, one metaphor that's kind of in the world that I like a lot is vertical drilling. Some kinds of data have granularity just in the world. We understand that cities are contained inside counties, are contained inside states, and they're a subset. Like the superset entirely contains the more granular data. And so we can offer users the experience of zooming in and out, and it makes sense to us. Geoanalytics, great example, because we've seen the pictures from spaceships that show the entire Earth, and then we're coming down, and then things get more granular. Timeline is also a good way, because a second is entirely inside a minute, is entirely inside an hour, is entirely inside a day, year, month, week. Week gets funky, so if any of you have to work with time data, not every month, I see some nods, not every month maps to 4 weeks. You gotta get tricky with it or remove it from your user affordances. Sorry?
Just use 2 parallel time hierarchies, day to week to year, day to month to year.
Day to week, yes, absolutely, yeah. So, and how do you inform a user about that?
Has a selection which level to drill down or up to, which hierarchy to use.
Exactly, yeah, and we do that. We do that in ingest, and you can use moment libraries, and you can have metadata that says Easter season moves every year, and this year it's April something to April something, which I'm going to totally talk about later in this presentation. I'm going to talk about windows. I wasn't going to talk about metadata, but now I'm going to. Going to the week to month granularity or seasons that don't fall on the same date every year, if you're analyzing, we have some clients who are consumer goods clients, and so they have seasons. We know when Christmas is going to be, and we know when Halloween is going to be, and we know what we sell for our Christmas promotions and our Halloween promotions, and we can do these timeline visualizations and compare year over year and see what's going on, compare them to our marketing efforts, see what's effective. But can't really do that with Easter because it moves. And so comparing well, actually, this is where you can do it with metadata, where you can just tell the computer, this year it's these days, and this year it's these days, and so look in between these days on this year. And that's how I've sort of done it in the past, is you just do a join on a calendar metadata. Or you can use operators like lag TS interval, or what we are going to come to, which is window operators, where you define a date range that sort of moves around. But first, we're going to leave the vertical drilling metaphor. Is everyone pretty kind of understand how like granularity and drilling make sense? Like because you're zooming in and out, just like you'd go deeper. So I love the idea of curation, and just because it makes so much intuitive sense when you're asking a user to do something to sort of make an experience for another user in this case. So like if you have a data scientist using a tool and they are going to tell the business analyst like their next steps in consuming a data visualization. So unlike like a geo map where you can zoom in and out and you have a predefined granularity, like a location-based granularity or area-based. Curated drilling is where you could like give a user a navigation path, like they can choose categories and they have to tell the system like what are connected, semantically meaningful categories. I sort of think of the example of like in stores, if you have jackets, you have data about jacket sales, and granularity would be like if you had subgroups totally contained in that, like you have down jackets and you have bolero jackets and you have trench coats. But curated would be if a user had to tell you, like, here's a dashboard, and here I want to see jacket sales, here I want to see pants, here I want to see shirts. They're just different types, and a human can tell you sort of what people are going to care about and tell the system. So we have some visualizations where a human being selects the dimension, and then you can click through. So things like tree map, which show proportion, you can have like a little stack of categories and then zoom in and out by category and then manipulate that with filters. The data engineers would know how to do that. Window operators, which I mentioned before. This one is moving average. Have you all seen these in stock charts where you have like your 52-week high and your 52-week low, and then it really smooths out like day or month, or in this case, year granularity. I don't actually remember what this picture was. It might be like a 5-year average, and then you have yearly average bumping around. And the reason why this is relevant is because of the aggregation levels. It's like 5 years in this case. And then you see how it smooths out and controls for spikes and valleys. So sometimes that's just really helpful in your visualization. I did some script examples. I think if you're really interested in implementation, there are much better educational resources online. But I was just thinking about aggregating over a whole data set and presenting that aggregate with the categorical breakdown. So this is just some data from hospitalcompare.gov. It's all the quality measures for reporting, so like aspirin on arrival. I filtered this data. I live in Oakland, so I'm always interested in Alameda County. I'm like, where do you want to avoid if you don't want to get a catheter-associated infection? And you can see from this chart, the line is the average over all Alameda County hospitals. And then the bars are the hospital reported scores.
Do you want a low number or do you want a high number?
You want a low number for this one. You want a high number for other ones, like percentage of aspirin on arrival for heart attack patients. But catheter-associated infections, lower the better. So don't go to Eden Medical Center if you need a catheter. So when I signed up to do this talk, I was like, and I'm going to show people how to use D3 CSV to just like iterate through your arrays and like do all this just straight from your CSV. But then even the hospital compare.gov data, that's like 65,000 rows, which is not a lot at a conference like this, but still is non-trivial when you're just kind of iterating through. So my actual advice there would be filter it, or do it in SQL. These are just some examples of the SQL over operator. How many of you do SQL programming? We just heard, okay, cool. So you might even know more about this. But just in my investigation over how to get an aggregate row level next to an individual value so that we can get a chart like this, this had some sort of good examples. So if you just don't specify a partition and you use over, it will aggregate over the entire data set. So for this example, select sum and cost over everything. But you can use other operators that are aggregation operators like rank. If you just want rank, if I wanted to create a chart like my little hospital compare.gov chart, I would use average over everything, which means you just don't specify a partition, so you don't specify a window. So like when I was talking about window functions, another kind of window is category. It's like the level of aggregation. You can have average salary over partition by department. Like if you want to sort of look at people's salaries relative to their department salaries and you want to aggregate over their department. And that way your engineers don't screw up the values. That was a joke because engineers are expensive these days, which is good news for us. It's great news for us. So that was a little discussion of the window operators, the SQL window operators, and some aggregation techniques. I would love to hear a little bit about what brings you guys here today, whether it's data visualization specifically, like how to lie with statistics, how to how to get big. There's a book about that. Is that how to get large data sets onto a small visualization, how to best communicate.
One of the interesting things that you brought up, I really liked, is the choices of choosing visualization types depending on the kind of data you have. And you're just limiting those choices to only what would be possible for that. And you do that really well. That's great, because I use Tableau, and Tableau kind of grays out.
Exactly.
Yeah.
But they're still in the interface, right?
Right.
Yeah.
So I'm sure in your like the whole data product, or even when you're designing a dashboard, there are so many such choices you would have to make where you could give a lot of options, configuration options for your dashboard. Even when you're making a dashboard, like you could add 15 sliders in there, which is great, but it also adds a lot of like it makes it more overwhelming for the users.
Yeah. It's funny, I think that some of our designers were very disciplined about choosing sort of where the presentation happens and where the more power user options are available. But even so, like even in our sort of exploratory area where you do have configuration options, where you have all measures from all data sets, you know, you're ingesting any data, you're doing your data modeling. Like here, I'll show you. I think it's still very minimal as far as interfaces go. So like, this is just example data sets with the many viz types. But you need, you can't have a scatter plot if you only have one measure. So I thought that was very clever too, yeah. I wish I could take credit for it. I have a predecessor, quite brilliant. I was also sort of congratulating our product because earlier we heard about the affordances for power users and how you don't want to be too busy, but you want to, and I was thinking specifically of like the long-running query example, where you want to say like, whoa, hold the phone, turbo, like that's going to take some resources, but you still want to allow users to do that if they're like, no, I really want the results of that query. Because this product is really for large data sets. That's the business use case, and our server engineers can handle it. And so having a UI that coaches a user without bothering a user is really, really helpful. It's funny, we recently implemented, or we're like in the next couple sprints, we're gonna be putting in a library called Clippy. So, because I sort of love Clippy and I want Clippy for data analysis. Like, it looks like you're trying to analyze data. One thing that our users have a ton of trouble with is this idea that all measures have to be aggregated. We have, here in our standard interface, we have all these buttons that are like max, min, standard deviation, like, standard deviation, I would sort of argue with including it because it is less helpful at categorical levels, because you're not, if you look at this and you see that you have, it's just standard deviation by year, it's not standard deviation over the whole data set. And there are other metrics that are kind of useless if you are including categories, simply because you need as much, like the less data, the less helpful it is. So.
On top of that, it's not robust. It's not robust to outliers, so if you're showing standard
Exactly.
you're really giving very little information.
And that's why it is less valuable at the best, misleading at the worst. You need as much, similar with things like p-value, you want it over the whole data set. You don't want to slice it down because it won't be helpful. But aggregating in order to put things on a chart is necessary, and sort of coaching people that they do need some aggregation operator if we're going to put it on an axis for you. So when you're trying to accommodate power users who want to know the p-value, and you're trying to accommodate people who just want to see a time series of like sales by year, and they don't want to have to ask IT for it, it's like the classic UX problem. Like, how do you accommodate, like, how do you make it simple enough for beginners and powerful enough for experts? So,
commensurate effort.
Sorry?
Reflecting the interface and commensurate effort.
Right, exactly. So we have, operator reference that's searchable. I really enjoyed the kind of like using the idea that the Power SQL interface used, where you sort of crowdsource, like, what data do other people think is interesting? Because if you have, 100 columns in the data, how do you know what is meaningful and what's just noise, what's sparse data? Because we're a big data analytics company, we get a lot of sort of automatically detected data, which has a lot of meaningless columns, like just lots and lots. So crowdsourcing that idea of like, and then bubbling up almost like a Stack Overflow model or a Google search results model.
Even so columns, and also a lot of times you would have the same table replicated in 15 different, 5 different, because in reality we want a single source of truth, but well, it doesn't happen like that.
Mm-hmm.
So you have 14 other tables which is not used ever, but you can't tell by the name of the table. So looking at the usage should help.
And trying to figure out what is the most current data set when you might have a user who has, for us, we have data connectors and then there's like an ingest process. But a user may have ingested old data more recently than the more current data, just depending on who it is and what they have available. So detecting like data set versioning, and then making that dynamic when some users want a lot of control. Like some users, they're like, I have this is our storyboard interface, which is kind of this top level like organizational idea where you can really see your data stories. And it's a dashboard tool. You've probably seen similar interfaces. And then how dynamic should those be? Because a business analyst, it was like it might be true, but I can't tell my boss. And some people want this old Excel metaphor. They want to be like, look, I have this chart, and it shows that my department is doing great, and it has 7 categories on the x-axis, and I like the way it looks, and I want to put, and I want to drag and drop images on it. I want chart junk. And they don't want it automatically updated. They don't want like March sales to make the line go a different direction. And they want this kind of like a presentational control. I get frustrated because of the principles of big data include velocity, and you just have to accommodate dynamic data. But I have to be sensitive to people who have sort of presentational interests because they're presenting this to an audience and they're making a recommendation or they're making a point, and they can get very insecure. And then sometimes like lower quality data, or they might question the data, and then their work, they can feel a real loss of control, and the tool failed them in some kind of significant foundational way. It puts them in jeopardy. So definitely, like, whether your tool is a presentational tool where you want users to have control, or whether it is a reporting tool and where you really want it just dynamic from the data source, or if you have like an IoT or any kind of like sensor or monitoring data, you don't want any control over the presentation. Like, you don't want to be like suppressing or I really enjoyed the talk about thresholds. Like, setting thresholds is another thing that can like change over time, Like, you have your dashboard, and red meant something different last year. Like, now your numbers have gone up, and what was green last year might be red this year. Like, if you're lucky, if you're crushing it, the thresholds change.
And if you're yellow, are you at the bottom of the yellow or top of
Exactly.
the yellow? Almost green or almost
Right,
green?
right. And it's funny, like when we, when we look at the opportunities that you give analysts to control the palette, even something like, I don't think this is overwhelming, but some people already think that this is way too sort of airplane cockpit-y for an exploratory analytics tool. And other people think like, boy, you don't really give people a lot of opportunities to control and present their data.
I'm trying to get my head around a couple things. One is, it seems very generic with the story, so I'm a UX person.
Mm-hmm.
I think about use cases or users and context, so
Right.
it's hard to, sort of generically think about these kinds of things. So I'm trying to understand that part of it more.
And that's sometimes a real challenge when you're building a generic tool, when you're not building for a specific data use case. Is that sort of what you're thinking?
It is.
Or are you thinking about the storyboard story metaphor?
Well, what I mean is that you're able to, that the tool, this generic tool, is relatively easily adjusts or adapts to the users or the needs. Because it's probably going to be, if there's a class of users that's using it, they're probably going to have things like cybersecurity, like times.
Absolutely.
So just how much does the machine figure out, or this tool figure out what's actually helpful or not, or that sort of thing based on?
We actually don't do a lot of sort of that crowdsourcing data recommendation. If that's what you're talking about, or are you talking about one thing that we've put a lot of thought into is permissions, and like data set permissions, row level permissions, what we call storyboard permissions, which are consumable at that level, but not, you can't modify them.
Intelligence of the system to know kind of what, to help the user know what to see, kind of.
Yeah, well, one of the strengths of our product is really in, and I think that this is considered the market differentiator, is the back-end intelligence that does data blending from multiple sources. So combining data sets and then useful visualizations without the SQL modeling tool, where you don't have to, like, where we detect joinable attributes, for example, and then join them automatically to create a data set underneath for selection and interaction. Am I answering your question? I don't know if I understood the question.
Basically, just saying from the presentation layer, purely
Right,
that
right.
there may be some intelligence to figure out what presentation layer shows in a particular context or particular users. You can probably make some guesses about optimizing, or at least starting off with a particular set of parameters for a presentation based on where it's being used or the sort of nature of the user.
That's actually a great idea, like a sort of rules-based, what is this user probably interested in?
Yeah.
From this analysis, it'll be a bar chart every time. I mean, I love bar charts, so.
One aspect to consider there is if you are deciding to make a change. So let's say, going back to the beginning of the talk where you're talking about different presentations at different aggregate levels.
Oh yeah,
So if I'm looking at the data
Right.
at monthly aggregate level and the system decides best visualization for that is bar chart.
absolutely.
I
Or-
go down to daily level, the system decides best visualization for that is a line chart. Now, to user, that's not necessarily expected behavior.
Yes.
As we know, users are okay with some surprises in the data. Users are not okay generally with surprises in behavior.
Yeah, I wouldn't recommend changing visualization type at drill level for that exact reason. Some drill levels, yeah, and the way we handle drilling is filters and then redrawing the visualization at the next, at the incremental lower level of granularity, unless it's a curated
Maybe
sort of.
I mean, more about the sort of levels of resolution or things like that.
Right, and I think of granularity and resolution
Right,
as the same.
Yeah.
Yeah. So you're thinking of different business users as being interested at different levels. Yeah, so this is, I had a conversation with a buddy of mine about like, what's your favorite level of aggregation? And I thought, and my first thought was like, I like over the whole data set, I like one value from everything, like, and I thought that was kind of like the super user, or the God view, like all the data and then aggregated to one point. And then I thought, oh, wait a minute, like that totally messes you up, because then you don't know about outliers, you don't know, like all kinds of things that you'll miss if you don't have granularity, if you don't have that resolution. And I was like, no, I take it back. Like no aggregation, like that's the best, because then you know everything about everything. I'm like, oh, except then kind of can't really, as a human, come to any conclusions. So it's probably somewhere in the middle, depending on your data set.
We've tried doing a sort of a good view thing,
Right.
a time series of box plots, which I personally love, but a lot of business users have difficulty understanding it. So it's almost like every time we have to use that chart for something, I need to sit down with business users and have a conversation about
What it
the birds,
means.
the bees,
Yeah.
the box plots.
Right. And you need to make sure you have enough data to have a real distribution. You need to make sure that it isn't already aggregated by year somewhere, because then you'll have a box plot that looks exactly like nothing.
So, sorry to interrupt here. Actually, one nice way to do it at times is those sparkline charts. Now, sparklines,
Yep.
yeah, oftentimes they're like these tiny line charts indicating trends, but you could also do it for the whole distribution, right? Like a histogram, like a tiny histogram under that one number that everyone wants to see. So,
Exactly. Yeah.
that tiny histogram at least tells you, look, there is some outliers.
Sorry I missed your talk because sometimes
Right.
I've seen sparklines so abused. They're wonderful in the right context, but sometimes they can be separated out and they don't have much. There's not much to see, and so you have a bunch of sparklines, but you can't make any meaningful comparisons
yeah.
visually.
Yeah, but I loved using, and this can be true of aggregation too, is like use it as sort of a click-through tool, you know, and then you can have your more informative or your more helpful visualization on mouse over, like, you know, like coaching the users after you've gotten their attention. And I got the T symbol, so thank you everyone, and thank you Data by the Bay. It's been such a pleasure and a privilege, so thank you.